For our last review, I wanted to review sulfur. We don't always talk about sulfur as one of the biogeochemical cycles, but I think sulfur is an important one to know about. And so some things that you should know about sulfur is that it's a component in coal. So when we mine for coal, I'm going to show like a little mountain over here. And let's say that we are doing some subsurface mining for coal. When we mine for coal, we uncover the soil that contains the coal, and that soil also contains sulfur. So one way that sulfur gets into waterways is through mining, which leads to acid mine drainage, which can have a yellow or an orange color because of the sulfur. If you've ever seen solid sulfur, it's a yellow solid. H2SO4 is the formula for sulfuric acid. So that can form when rain or water, natural bodies of water, carry the sulfur that was bound in the soil and was uncovered through mining. So that's one way that sulfuric acid gets into the environment. And then sulfuric acid, as we mentioned with nitric acid, acids are really good at reacting with things. And so that acid can react with other elements in the soil or rock, and it can cause them to be released as ions or metals into bodies of water, and that can be really dangerous for the organisms that live there. So that's acid mine drainage. The other way that the sulfur can form sulfuric acid is when we burn coal. So if we draw our power plant over here, and this power plant is burning coal, that's going to release sulfur dioxide into the atmosphere. And coal is known for being one of the dirtiest fossil fuels because in addition to carbon dioxide, it also releases things like nitric oxide and sulfur dioxide. So the sulfur dioxide can contribute to what's called industrial smog, which was one of the first smogs that was discovered back in London in the 1800s when they were burning a lot of coal as part of the manufacturing process and industrial revolution. So industrial smog is a combination of sulfur dioxide with other atmospheric components. And then some of that sulfur dioxide can also combine with water vapor to form acid precipitation, which can then be deposited through acid deposition. And so that's going to be sulfuric acid, or H2SO4 again. And we know that acids can damage living things, and also they can dissolve rocks and stone, just like they did here through the acid mine drainage. One natural source of sulfur dioxide would be volcanoes. So if you wanted a natural source of sulfur dioxide, you could also add a volcano to your drawing. And volcanoes were linked to some of the mass extinctions. So if you think about the history of life on Earth, some of the periods of time where many of the living things on Earth went extinct were due to massive volcanic activity, because that volcanic activity also resulted in a lot of exhaust that triggered changes in climate, blocked the sun, think about smog, made it difficult for living things to breathe, formed acids in the atmosphere that then affected organisms that required a certain pH in order to survive. So one thing I like about this class is the way that everything is sort of connected.